So what I'm going to do today, and thank you all for having me here, and great pleasure to be here at Buckingham again, is to first of all explain what global catastrophic risks are and say something about the forms that these take, because the form they're taking now is rather different to the form that they've taken historically. Then I'm going to explain why we should be worried about this, even though in many cases these are low probability events. And then finally I'm going to say what we should do about them, which is where the economics comes in, because if you need economic insight and economic arguments to be able to understand what the best way to approach the challenge of global catastrophic risk is. Although I have to say a lot of economists have dropped the ball on this issue and have not been covering themselves in glory when they discuss these matters. So what is a global catastrophic risk? Well, it's a special case of the wider category of risk. A risk is a possible event with a defined probability of happening, which if it does happen, will cause costs or inflict costs upon the people who are the object of the risk. The extent or scale of the cost is determined by the measure of the damage, the loss caused by the risk should it happen, plus the cost of making good that damage. In other words, we're going back to the status quo ante. So those two factors together give you an idea of what the damage is. The actual scale of the risk itself is produced by multiplying that damage, potential damage, by the probability. So if you have, let's say, a £1,000 damage were the risk to happen, and it's a 1% risk at any given time period, that means that the actual value at risk is 1,000 divided by 100. So that's the standard actuarial calculation. Now that's risks in general. You don't always know what the probability is, by the way. This is a very serious problem in many cases, because in many cases you cannot establish a clear probability for a particular risk happening. And this is particularly the case actually with very large scale or rare kinds of risk. So the lower the probability actually is, the more rare or infrequent the risk event is, the more difficult it is to establish the probability. This is a problem for global catastrophic risks in particular, as I'll explain in a moment. Now, a global catastrophic risk then is a risk in that wider sense, which has two features. The first is that it is global. It affects the event concerned, if it were to happen, would affect not just a part of the world, but the entire planet. That's what the global bit means. The catastrophic bit means that the consequences or costs of the event, if it were to happen, would be absolutely massive and irreparable. In other words, the cost is either really, really, really big or even infinite. Now, this is a very specific category. All kinds of things that are often thought of as being risks of this kind are not. So, for example, a nuclear war in the Indian subcontinent or in the Middle East would be catastrophic for that part of the world, but it would not be a global catastrophic risk because it wouldn't affect the entire planet. Conversely, a pandemic like COVID is certainly global, it affects the entire world, but it's not catastrophic because it doesn't produce costs and damages which are absolutely fundamental and impossible to make good. So a global catastrophic risk is a very specific kind of possible event. It's an event with global effects which has catastrophic results should it happen. Now, what does catastrophic mean in this context? Well, the philosopher Toby Ord, who has written about this extensively, notably in his book The Precipice, which came out a few years ago, defines catastrophic as being something which permanently and fundamentally impairs any prospect for future human flourishing. And for him, that really means three kinds of event. One, human extinction. Obviously, human flourishing is not going to happen if the human race is extinct. That means the whole future of the human race ceases to be a virtual possibility, becomes an impossibility. Secondly, the irretrievable collapse of civilization. If civilization collapses and is destroyed, and there's no chance of its ever recovering, that means that all of the kind of human potential futures that could have existed had that collapse not happened will no longer be within the realm of possibility. and that's also a catastrophic loss. The third loss, which he emphasises, but which several of the other people who've talked about this, notably his colleague at Oxford, Nick Bostrom, do not consider, is that of an indefinite future tyranny. Ord is very exercised by this. So if you imagine a world in which you have a hyper-efficient kind of tyranny, which is so pervasive and so powerful that there is no realistic prospect of its ever being overthrown or collapsing, that would radically impair human flourishing in the future, even though the human species would exist. Those are the three kinds of event which fall into the category of global catastrophic risk. Human extinction, if you like, is a kind of subcategory. That's an existential risk, which is a kind of a very extreme form of a global catastrophic risk. So that's what they are. Now, several points to make about the probability of the kind of events we're talking about here. The first is that what we're talking about here is probabilities, not, and I repeat, not in capitals, predictions. When I'm talking about this, I am not saying that the kind of events I'm going to be talking about are going to happen. What I'm saying is that there is a chance that they could happen. It's a bit like being told by the doctor, not that you have a terminal cancer diagnosis, but that there is a probability that you might develop a terminal illness in the future, which is not the same thing. The point is, though, that you should take that seriously. So if the doctor, for example, tells you, well, you know, if you go on as you are, there's a 1 in 10 probability that you will develop type 2 diabetes, you should, you know, take account of that. Even he's not saying you're definitely going to get it, but he's saying that, you know, you're definitely got a measurable risk of this happening. Similarly, if a doctor says to you, well, if you continue to smoke, you know, the chances that you will develop a terminal cancer are significant, or arteriosclerosis and a stroke are significantly higher. Again, you should take note of this. So I am not talking about predictions here. What I'm talking about rather is bets, if you like. And when you're dealing with an event of this kind, which is an event typically with a low probability, but an absolutely catastrophic cost if it were to happen, maybe even in the case of extinction, an infinite cost, then you should take this seriously, even if the probability is low, because although it might be a low probability, if it were to happen, it would be quite literally the end of everything. And so therefore it is worth you know, taking at least some time to think about it. The second thing to make, a point to make at this point, is that the probabilities, as I said a moment ago, are very often extremely hard to establish. And that's because events of this kind, catastrophic events, are sometimes, not always, alarmingly, but sometimes very, very rare events. They do not happen very often. Now, what that means is that there aren't enough data points, past events, for us to be able to establish an accurate estimate of the probability of such an event happening using the law of large numbers. This obviously makes it very, very difficult. You know that a certain kind of event is possible, but you know that if it did happen, it would be absolutely desperate, but you have no past evidence, no run of data points to enable you to establish the probability. In addition, in many cases, the costs of events of a certain kind are produced by a small number of such events. In other words, you have a number of kinds of event where the consequences, the negative results, the costs, are produced by a very small number of the causal events. So you have a highly fat-tailed probability distribution. This makes predicting the likelihood of one of those big events very difficult. An example of this is pandemics. If you look at the last 2,000 years, we've had just under 30 genuine pandemics in that period. Of those 30, by the way, over 20 have happened since 1815. So pandemics are becoming more likely. But if you look at the impact of those pandemics using the proper metric, which is the proportion of the world's population killed by any given pandemic, as opposed to absolute numbers, by that criterion, over 90% of all of the deaths caused by pandemics were caused by just 3 of them. The Black Death, the Plague of Justinian, and the Great Smallpox epidemic of the 3rd century, which we call either the Plague of Cyprian or the Antonine Plague, depending on which wave of it you focus on. So that's a highly fat-tailed distribution. Virtually all pandemic-related deaths are caused by a very, very small number of extremely large but low probability pandemics. And that makes predicting the probability of such an event extremely difficult. So that's the second sort of point to make here. Now, what kind of events do count as global catastrophic risks? Well, in a way, you should be able to think about this quite easily. So anything which would either wipe out the human species or which would completely and irretrievably destroy human civilization or the future prospects of human flourishing counts as a global catastrophic risk. Now, historically, human beings have always lived under the shadow of a certain number of global catastrophic risks. But historically, these were natural events, and they were typically very low probability, and also, crucially, they were events over which human beings had no control. An asteroid striking the planet, for example. Nothing our ancestors could do about that, but there's always the risk that we will suffer the same fate as the dinosaurs, that we'll have something like the Chicxulub event where a major asteroid will strike Earth and obliterate most life on it. Another possibility, which is even lower probability, is that there will be something called a basalt plain ejection, which is something that happens roughly once every 300 million years or so in the Earth's geological history, in which you get a kind of enormous megavolcanic eruption which floods a large part of the planet's surface with lava. This is something that happens roughly once every 300 million years or so in the Earth's geological history. In this, you get a kind of enormous megavolcanic eruption which floods a large part of the planet's surface with lava, producing a basalt plain, hence the name for the phenomenon. This has, on at least 2 occasions, come close to eliminating all life on Earth. So this is a kind of threat not only to human beings and human civilization, but to life in general. Fortunately, though, as the timing says, it's an extremely low probability event. And once again, it's one over which human beings have no control. A third example of this category of continuing natural global catastrophic risk, something our ancestors always had to live with, is that of a supervolcano. A supervolcano is, by definition, a volcanic eruption which throws at least 1,000 cubic kilometers of fractured rock into the planetary atmosphere. There are a number of supervolcano sites around the planet, such as the very large caldera underneath Yellowstone National Park in the United States. Supervolcano eruptions happen much more frequently than basalt plain events. They happen on average about every 70,000 years. If one were to happen, it would undoubtedly destroy human civilization beyond recovery. Now, this is a much more high probability risk, and in fact, there has been such a volcanic eruption, a supervolcano eruption, within human history. The one that created Lake Toba in Sumatra about 70,000 years ago, and which resulted, according to many paleoanthropologists, in the human population being reduced to only a few thousand breeding pairs. I should say there is dispute about this, but there's no doubt that we had as a species a very close shave on that occasion. Now, those 3 are examples of global catastrophic risks that are both natural and beyond human control. There are others that are within human control and which may alarmingly be increasing, something I'll return to in a moment. One of these is the risk of climate change, or to be more precise, of an abrupt and sudden climate flip. Climate change per se, or global warming as it should be better called, is not itself a catastrophic risk. If the planetary temperature rises by 2 to 3 degrees Celsius over the next 100 years, then that would be really bad. I don't mean to minimize what the scale of problems are that would cause, but it would not be catastrophic because human civilization would have time to adapt at great cost, but it would be able to continue. What is much more serious and threatening is the prospect of a sudden and abrupt reset, if you like, in the planetary thermostat, in the default setting of the planet's weather system. Now, this is a realistic and serious threat, and it's one that our ancestors also faced, because such resets have happened many, many times in the Earth's geological history, and on several occasions in Earth's recorded history, always with very far-reaching and extensive results. So, for example, between 1585 and 1596-97, the Earth's temperature declined by about 1 degree Celsius, and it then fell by another half a degrees Celsius over the next 60 to 70 years. This had major and very destructive events all across the old world civilizations. And for reasons that I'll come on to in a moment, an abrupt climate change of that kind would have truly catastrophic results for global civilization. Now, that is an area where it may well be that human activity at the moment is making such a reset, an abrupt flip, more likely. It's also something, however, that we can deal with in various ways, or at least attempt to mitigate. It's worth saying, by the way, that generally in the past such resets have been in the direction of a colder climate at the moment. But what we may well be confronted with at the moment is a reset to a much warmer and paradoxically more equal climate, one in which the temperature gap between the equator and the poles is much reduced. Now, there are some rather alarming signs that one such reset may actually have started, but we will actually know whether there is such a reset going on or not very quickly within the next 18 months or so. Now, these are all natural risks that human beings have always faced. They may be more acute at the moment, or the cost of them would be higher at the moment because of the greater development of human civilization, but they're not new. However, we are now, in many ways, in a much more vulnerable position than our ancestors were. We face novel risks, and many of the older risks that we face are becoming exacerbated. Now, there's a number of aspects to this, but the underlying common phenomenon is that these are produced by novel technologies or by the impacts of novel technologies. Paradoxically, our economic development and technological development is actually making us more vulnerable to global catastrophic risks rather than less, which is a counterintuitive conclusion. Why is this? Well, there are several reasons. First of all, our technological development actually means that certain events that would not have been catastrophic risks in the past now are, because of the impact that they would have. The classic example of this is what is known as a coronal mass ejection, which is when the sun spits out a large mass of highly energetic plasma. The most famous historical example of such an event is the so-called Carrington event, which took place in 1859. Now, solar storms of this kind occur on roughly a 100-year average. So in any one year, there's a 1% probability of an event of the Carrington event size and scale. Now, when the Carrington event happened, all that happened was that our ancestors got a lot of spectacular northern lights and a few telegraph cables and stations burned out. However, if such an event were to happen today on that scale, then it would crash grids all over the developed world. It would also burn out large amounts of electronic appliances and crash most electronic systems. And this would not be a temporary or short-lived event. A report commissioned by the US Department of Defense and another one undertaken by Lloyd's of London both conclude that the impact of a Carrington event-style solar flare would be on the order of a reduction of 17.5% of GDP. This would be quite simply a catastrophe. And it is an example of a phenomenon whereby something which in the past would have been a natural phenomenon that was harmless has now become deeply harmful precisely because it would affect the technologies upon which we all now depend. The second way in which we're more vulnerable is that new technologies themselves bring along enormous risks along with the benefits that they bring. The obvious example of this is artificial intelligence. Artificial intelligence can obviously bring enormous benefits, but there's also the alarming possibility that we create a superintelligence which decides that human beings are redundant or actually a nuisance and decides that it is going to exterminate us. Or you could have an AI which is not sentient and doesn't consciously or willingly desire to exterminate human beings, but which has enormous power because we put it in charge of a lot of systems, and which is badly programmed or badly designed, and as a result produces disastrous results, which have the same ultimate effect. Another example of this is genetic manipulation, using technologies like CRISPR and Talon. Again, this has the potential to bring enormous benefits, but it could also produce disastrous or catastrophic outcomes, such as, for example, the production of new kinds of pathogen. All of this means that many of the new technologies we're producing are coming with enormous potential downside risks. And as we'll see, this means that we have to think very carefully about the trade-offs that we might have to make between defending against those risks, hedging against those risks, and the possible gains of them. Now, what makes things even more alarming is that many contemporary technologies and economic developments are elevating natural risks. One of the continuing natural risks that we face is that of a truly devastating pandemic. A pandemic, that is, on the scale of, let's say, the Black Death or the Plague of Justinian, which means one that would take away or kill 45 to 50% of the planetary population. Now, if we look at the history, we can roughly estimate that the chances of a natural pandemic of that severity are about a 700-year event. What we are doing at the moment through various things, and in particular the way in which we produce meat through intensive livestock farming, is to roughly double the relative risk of that happening. So instead of being a 1 in 700-year event, it's now becoming a 300-year event. Now that means that there's a 0.3% probability in each year, and a 0.3% probability of 50% of the planet's population being wiped out by an infectious disease is way too high. And that's a natural probability which is being elevated, exacerbated, if you will, by technology. In this case, the way in which livestock farming is conducted. But it's not the only example of this. There are other instances where the way we've chosen to apply or use technology is making natural risks greater. There's also, related to this, the way in which technology is making our systems of society, economic systems, administrative systems, social systems, excessively complex and therefore brittle and susceptible to catastrophic systemic collapse. This is linked to the problem of excessive efficiency, using resources to their fullest possible extent with no slack or margin of redundancy. This sounds very good if you're an economist, but actually it's not, because it means that you're much less resilient, much less able to cope with unexpected or unanticipated shocks, or even anticipated ones, if you don't allow for them in the way you run things. And one of the reasons why many events that in the past would not have been catastrophic are now. So, for example, the Black Death, although it was a great catastrophe, did not end civilization in the old world. The Eurasian civilizations survived the shock and in some ways actually flourished after it. But if we were to have a pandemic today that took off 45 to 50% of the planet's population, it is very unlikely that the systems we now depend upon and the complex civilization that they support or are part of would survive such a shock. And that would obviously be a kind of catastrophic disaster of the kind that is defined by Toby Ord. And this brings me to the final way in which currently we are in a moment, if you like, of unique or severe vulnerability as far as global catastrophic risks are concerned. This is that should we have a civilization-ending disaster, it will be much more difficult than many people suppose for civilization to ever recover. It's worth saying that in this case, I'm actually more pessimistic than Toby Ord is. His view is that actually a civilization-ending event, which is permanent and irreversible, is much less likely than the risk of human extinction. I disagree quite strongly with that. I think that the chance of an irreversible collapse of civilization is significantly higher than human extinction. And the reason is this. The civilization we have, the high-energy, high-tech civilization of modernity, has used up and consumed most of the easily accessible resources of various kinds. Above all, energy, but also things like high-grade minerals reserves of various kinds. Now, that is not a problem as long as we have a high-tech and high-energy civilization. We can just use lower-grade ores or switch to more inaccessible and hard-to-use oil reserves. However, if we lose that high-tech civilization because of a disaster or a catastrophe of some kind, then we will not be able to reconstruct it, because by definition, we will not be able to use the low-grade ores and difficult-to-access energy reserves that are still left. We're in the situation of somebody who is climbing up a ladder and with each step the rung is broken And if you then fall down that ladder, it means that you can't resume your climb because there are no longer any rungs in the lower part of the ladder. And so what this means is that until our technology develops to a point where that no longer applies, we're in a window of extreme vulnerability. If we fall off the ladder of high-tech civilization, it is very unlikely that we will be able to reconstruct such a civilization. We will still have a civilization of some kind, like the ones we've had in Earth's past, but the whole prospects and possibilities that are in existence at the moment as virtual futures that might come about because of the technology we have would suddenly become completely impossible, and therefore a whole range of types of human flourishing would not be possible. Now, what should we do in response to this? Well, there are various things that you can do. There are certain kinds of protections you can take against these kinds of catastrophic risk. You can, for example, engage in what is known as lifeboat measures, where you have a series of institutions or sets step up which will protect human beings in a minimal way, even against really severe, massive natural disasters, such as an asteroid impact or a supervolcano eruption. These are things like the Svalbard seed vaults, where you preserve knowledge or basic resources in remote and geologically stable parts of the world, so that subsequent generations of human beings after the catastrophe can reconstruct at least some kind of civilization. But there are other more practical things you can do to either prevent an event becoming catastrophic or to mitigate it should it happen. One example of this is the way in which you can project against a major coronal mass ejection, a Carrington event. You can do things with this by changing the way the grid is organized, which you should probably be doing anyway, and by hardening the grid and economic devices, or certain key things to protect against the kind of power surge that a major coronal mass ejection would have. By the way, I should add that in 2012, a storm of greater magnitude than the Carrington event happened, but the mass of plasma, the mass ejection, missed the Earth by about 20,000 miles. Which in terms of interplanetary distances is like nothing. That's like having a bullet go past your ear, it's incredibly close miss. So we should take that risk seriously, and it's worth devoting a reasonable amount of resources to hardening against it. And the report I mentioned that the US government has developed does actually say this. It's worth doing for other reasons, of course, because the use of the detonation of a nuclear device in the stratosphere to generate an electromagnetic pulse is also part of possible nuclear warfare. So that's something you want to protect against for those pragmatic reasons. And there are a range of risks of that kind. The more tricky question comes with the question of things like hypothetical or potential technological risks. You need, so for example, AI or genetic manipulation through techniques like CRISPR. These are both potentially enormously beneficial, but also enormously potentially risky. The upside of AI, we can do all kinds of things. The downside is it may exterminate us. The upside of genetic manipulation is we can cure a ton of diseases, we can extend human lifespan radically, we can do a whole lot of cool stuff. But the downside is we might produce, for example, a novel pathogen and accidentally, or even worse, deliberately release it and kill like the great bulk of the human population. Or we could accidentally produce, for example, a variety of plant which wipes out a major food stock. There are all kinds of possible risks. Low probability, but not low probability enough that we can afford to ignore them. So the difficult question then is, do you restrain the technology? Now, in other words, do you impose technological controls and forego those benefits in order to reduce the risk to an acceptable level? A lot of AI people have said that there should be a very short, probably 1 year pause in all AI research. I tend to favour this myself if it could be made to stick, because the arguments for it is that AI is now accelerating at such a rate that we need a pause simply to try and work out what the likely problems are and what kind of steps would need to be taken in order to guard against the kind of risks I'm mentioning. One of the conclusions I've come to is that really it's a great time to be a Kantian, because what you do not want is to have an AI that is a consequentialist ethically, because the AI will probably think, well, the way to maximize human utility is to exterminate a large part of the planetary population. So you're like, no, let me explain this thing about deontological ethics to you. Certain things you just don't do. So if you assume that you can program or design the moral architecture of artificial intelligence, which is a big question, by the way, then that's one of the things you need to think about. But it is a difficult decision to make, and that's one of the reasons why I think you need economic insights. You do need to try and work out what the balance is. Now, this does involve calculations, and I'll wrap up here, some of which are quite bizarre. So William MacAskill over at the University of Cambridge has written a book recently called What We Owe the Future, and he has done a kind of reductio ad absurdum in pure utilitarianism, where his argument is that, well, we should take account of the interests of our descendants. And if you do some pretty standard calculations, there are trillions of possible future descendants. And so his argument is that the interests of these trillions of possible future descendants should outweigh the interests of people who live here and now. Therefore, we are justified in even actually making the condition of people now significantly worse if by doing so we ensure that these trillions of future descendants will come into existence and enjoy whatever he thinks might come. I think that's a classic example of a reductio ad absurdum. It shows you that while you need to take account of future generations, you shouldn't give them a kind of equivalent, but you do have to apply some kind of discount, basically. Otherwise, you're going to end up with some truly bizarre conclusions. The question, when this is a difficult one, is how big should that discount be? What I'm saying about a lot of contemporary economists is that they apply too large a discount. They discount future interests much too strongly, for me, compared to what they should be doing, particularly in the context of risks of this kind, where the consequences, even for the current generation, never mind the next or the next 2 or 3, which is a reasonable length of time to think about, would be absolutely disastrous. So there's all kinds of calculations, things we need to think about in this context. But what I think is that this is a subject that we can't avoid thinking about or talking about, simply because we are at an unusually vulnerable point in our history as a species. We've evolved to a point where the level of our technology has presented us with a whole lot of novel risks, made a whole lot of previous risks much worse than they were before, but has also produced a system where we are highly vulnerable. In another 100 years, if we continue to develop, this will not be the case, we'll be more robust. But we've got a rather tricky 100 years to get through, which is the point the Astronomer Royal made in a book with the rather arresting title, Mankind's Last Century, a few years ago. And that's the point at which I'll stop.
Thank you.